This is the first part of a two-part video on Euclid Book 3, proposition number 31, and you're going to see why we're going to have two parts to this. First of all, Euclid wants us to prove three things. I don't know why he didn't make three different proofs, but he didn't, so we're going to prove three things. Number one, he wants us to prove in this circle. Now, before we do any proof here, we got to draw a circle. And this circle starts at letter A, it comes all the way down here to letter B, comes all the way up here to letter C, goes all the way to letter D and back to A. So we've got a great big circle here. And then we've drawn some circle radii. The center of the circle is at E, and you can prove this by Euclid Book 3, proposition 1. But anyway, we have E to C, E to B, both of which are radii of this circle, and also E to A, which is another radii of this circle. And then Euclid says, all right, I want you to draw a line from point A to point C, and then I want you to draw another line from point A to point B. Here we go. Euclid then says, I want you to draw two more lines. I want you to draw a line from point A to point D, another line from point D to point C, and he says, and I want you to draw one last line from point A to point F, which is going to be outside the circle. All right. Euclid first says, I want you to prove that angle BAC is equal to 90 degrees. Well, where is BAC? Well, we have to start from here. There's B there, there's A there, there's C there. So this whole thing right here is going to be 90 degrees. Okay? And then he says, although we have this segment of a circle from A to B to C, and we can automatically see that this segment right here, because AC cuts off this great big segment of the circle here, we can see that this segment of a circle is bigger than a semicircle. Remember, semicircle is only half of a circle. It's exactly one half of a circle. So we can see here that the area covered by ABC here is going to be more than half of the circle. Okay? Even though that's true, then angle ABC, which this is A, this is B, this is C here, this angle right here is going to be less than 90 degrees. Now, angle right there is going to be less than 90 degrees. And then he goes on to say, all right, we have another segment of a circle. It's also cut off by AC, and it goes from A to D to C. And you can see this is a smaller segment of a circle, okay? But he says that even though this is a smaller segment of a circle, that angle ADC is going to be more than 90 degrees. Okay, how do we prove all this? Well, it's going to take at least two videos to prove this. All right. We're going to say that BE, this length right here, EC, this length right here, and EA here, this length right here, are all equal in size. If you were to measure all three of these lines here, they'd be all equal in size because all radii of a circle are equal. And this is very important. Alright, if BE, here's BE here, and EA, which is this one right here, if these two lines here are equal in size, which we said they were, then angle ABE, well, here starts A, goes to B, goes to E, so this angle right here, and angle BAE, which BAE, that would be this angle right here, these two angles here are equal in size. And we can say this by Euclid Book 1, proposition number 5, so if you don't know what I'm talking about, you have to go back. Anyway, we now know that these two angles here are equal in size. We can also go on to say that CE and EA, these two lines right here, are equal in size. If you were to measure them, they'd be equal in size. Because of this, and because of Euclid Book 1, proposition number 5, we can also say that ACE, this angle right here, is equal in size to CAE, which is this angle right here. So this one and this one are equal in size. Alright, now we know that angle BAC here, is the sum of ABC, this one right here, and the sum of ACB. So if you were to add these two angles together, the number of degrees in both of these, you'd get this one right here. And we also now know that FAC, this angle right here, is also the sum of angle ABC and ACB. If you were to add the number of degrees between this one and this one here, you get the number of degrees of FAC, which is right here. And we can prove this by Euclid Book 1, proposition number 32. All right. That means that BAC is equal in size to FAC. Okay? So these two angles right here are equal in size. And by Euclid Book 1 definition number 10, Book 1 definition number 10, we can say that BAC, angle BAC is 90 degrees, and we can also say that FAC is 90 degrees. All right. We can then go on to say that if we were to add the sum of ABC and BAC, now where are these angles? Okay? ABC, this is A, this is B, this is C, so the sum of this one here and BAC, well, here's B, here's A, and here's C. So if we were to add this angle here and this angle here, the number of degrees between these two right here, we would come up with a number of degrees less than 180, which is by Euclid Book 1, proposition number 17. So therefore, we can all go ahead and say that angle ABC, okay, ABC here is going to be less than 90 degrees. Okay? So, you say, well, how do we figure that? Well, we already established that BAC is 90 degrees. So we have to have an angle here at ABC which is less than 90 degrees, because if we had 90 and 90, that'd be 180, and therefore it wouldn't be true that if you added the number of degrees in here and here, you would have less than 180 degrees. Therefore. Alright, I will tell you more in the next video, so stay tuned.